Hi guys, so today we're going to be learning about coordinates in space, and basically we're going to be graphing 3D objects. I guess similar to our whole isometric paper and stuff like that, but it's going to be on kind of like a coordinate plane now, okay? So before we get started with example one, we're going to be talking about graphing solids in this space and what the point looks like. So to describe the location of a point on the coordinate plane, we use an ordered pair, right, of two coordinates. In space, however, because space is 3D, each point requires three numbers or coordinates to describe its location because, like I said earlier, space has three dimensions. In space, the x, y, and z axes are all perpendicular to each other. So it's a little bit hard to see on this 3D thing, but essentially it looks like this. Here's our x and y, and then z basically sticks up like this. And so we're basically graphing in this three-dimensional space on this two-dimensional paper. Okay, so a point in space is represented by an ordered triple of real numbers, x, y, z, in the figure here on the right. The ordered triple 2, 3, 6 locates the point P. So notice that a rectangular prism is used to show this perspective, that it is 2, 3, and then 6. Okay. So x equals 2 is from here, right? So it goes this way, right? So this is positive, this is negative for our x-axis. So 2, you see 1, 2, and then we draw this line, okay? And then 3 here, you'll see a line here, right? This is where the 3 is, and so this line for the x is now going to be parallel to the y-axis, and this line for the y is going to be parallel to the x-axis, and then 6 up, you just measure how far is 6 up, and then that's how far up you go. Okay, so it is going to be a little bit challenging, this lesson, so just stick with me. Okay, and then whatever part you're confused at, maybe watch it over again, maybe read the book at the same time, and then hopefully that will help. Okay, so we're starting off with example one. We're going to graph a rectangular solid that has a, -4, 2, 4, as well as the origin as vertices. And then we're going to label the coordinates of each vertex. Okay, and so because of just the challenging nature of it all and the fact that I'm going to be erasing some stuff, I'm going to be using pencil to help me out. Okay, and so let's get started. Okay, and I'm going to get my ruler. Okay, so here I have the point -4, 2, 4. So I'm going to start off with x, which is -4. So going in this direction, -4, 1, 2, 3, 4. Here's -4. Okay, and then I'm going to basically draw a line as best as I can here at x is -4. That's parallel to the y-axis. Okay. Then my y here is 2. Okay, so that's 1, 2. Right? And then I'm going to draw that parallel to the x-axis now. As best as I can. Okay. And so then where this meets, right here, is -4, 2 in space. Okay. Then I want it 4 units high. So then this part here, parallel to Z. Okay. I want it 4 units high, so I'm just going to kind of measure how long that is. So that's about 4 units high, is about there. So I'm moving here and up there. So -4, 2, 4 is here. And so this is A at -4, 2, and 4. Okay. So with this, I kind of already see kind of a 3D shape, right? Let me kind of highlight it here. And maybe I should use another color. Okay. All right. So here, this part if I'm using also the x-axis, this is one of the lines. This is another line. This is another line. Right? And so here, now I can kind of see my 3D shape. Right? Okay. And then, so here, if I also go can also go 4 units high, which is again approximately this long. Moving it here. Right? So then I can draw this now. And I can connect this here. Right? I can go across here. Okay. Go down here. Okay. And then now I just need 2 away. So if this is, how far is 2 away? It's about that. Sorry, I lost the measurement. It's about here. Oh, holding it down. About here. The other point, connect. Wait, that was bad. And then, there you go. There's my prism. Okay. So it's kind of difficult to graph, but at least as you're graphing this first point, it kind of helps you draw the lines that you need for the other ones. Okay. So this one here, okay, this point will be considered 0 to 0, right? Because it doesn't go off of the x-axis in any direction, but it goes 2 in the y and it doesn't go up. Okay. This point here would be -4 to 0 because it's not up any higher. Okay. This point here is -4, 0, 4. Okay. This point here is 0 to 4. 0 to 4 because everything up here is 4 units high. Okay. This one here is 0, 0, 4. And I think I got all of my, oh, I still have my back one. Okay, so I didn't draw the back dotted one. It's a little bit hard. Beep, 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 beep. Beep, 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 beep. Beep, beep, beep. Okay, and then this one here, getting a little blurry. That point here is 0, 2, 4. Okay. So I know it's a little bit confusing, especially in 3D space. So it's okay. It's just part of a learning process. Just try your best, and then as you need help, just contact me, and then we can set up a Zoom call to talk about this. Okay. Okay. So why don't you try CYP1B to the best of your ability, and then once you're done, come check your answer. And if you still don't get it, that's fine. You can just come and see the explanation. Okay, it should look something like this. Okay, it's okay if you got it wrong. Just try your best. Hopefully you were at least able to graph 4, -5, 2, because that's really what helps you kind of create the rest of it. Okay, so if you got that right, you can move on to the next example. If not, here is your explanation. Okay, so here I first started at x here is 4. So on the x-axis, I went 1, 2, 3, 4, and then I drew this dotted line. Okay. Then, using y as -5, okay, then I went 1, 2, 3, 4, 5, and then I drew this line here parallel to the x-axis. And so right now, this is 4, -5. Okay. Then, since z is 2, I need to go up 2 units. So I just measured how far that is, right? And drawing this line vertically, I measured how far that is, and that's what gave me 4, -5, 2. Okay. And then by then I have this line, and this line. And so here, connecting this and this gives part of the box, and this. Okay. And then so I know that the box is 2 units high, right? Because z tells me how high it is. So then I just went 2 units here to get the next point, 2 units here to get the next point, and then I just connected them here. And then by then, I know I need to go across here for that, and across here for this, and then I just connected it that way. Okay? So it is a little bit hard to see visually, and then especially with all the lines. And then after that, I just labeled each of the coordinates. So this one is 4, negative 5, 0 because I don't go up. This one, all I did was from 0, 0, I just went along the x-axis 4 units, so that's why only the x-axis changed. Here, nothing changed except I went up, and so that's z, so that's with the 2 units. And then with that, I can piece the rest of it together, okay? So up here on this surface, it all is 2 units high, so all of them here, you see that z is 2 here, and z here is 2. Okay, versus everything on that bottom base doesn't go up, so that's why their z is 0. And that's kind of how you kind of slowly piece things together, right? So for this lesson, I would definitely take my time on it. You just kind of learn it through trial and error. Like just try connecting lines, see if you can see that shape, and then I would definitely use pencil to kind of connect before I feel very confident with it. Okay, so the next part is a little bit easier. Now we're just talking about distance and midpoint formula in space. It should look pretty familiar. The only thing now is we're adding in our z, right? So here you would recognize this as our distance formula from before, and now all we're doing is adding in the z coordinates. So z sub 2 minus z sub 1, and then squared. Okay, so same thing with the midpoint formula. Right, you would recognize this previously as our midpoint formula, and now all we're doing is adding in for our z coordinates. Okay, so with that in mind, we're going to do example 2. So determine the distance between t and q. So distance equals square root, right, should be pretty familiar to us, x1 minus x2, so 6 minus negative 2 squared. Right, plus y minus y squared, so 0 minus 4 quantity squared, and then z, this is the new part, 0 minus 2 squared, right? So you recognize this part as the distance formula. All we're doing is now also doing it with our z coordinates, okay? 6 minus negative 2 is 8, so 8 squared. 0 minus 4 is negative 4, so negative 4 quantity squared, and 0 minus 2 is negative 2, so negative 2 quantity squared. Okay, let's do it here. 8 squared is 64, negative 4 squared is 16, because it's negative 4 times negative 4, and negative 2 squared is 4. Okay. 64 plus 16 plus 4 is 84, so square root of 84, and then if I simplify the square root of 84, that gives me 2 square root of 21, okay, and so this is my distance between the points, okay, so how do I find the midpoint? The midpoint m, right, halfway. So I'm going to add the 2 and divide by 2. So 6 plus negative 2, divide by 2. 0 plus 4, this is my y's, divide by 2. And then the only thing now is we have our z's, 0 plus 2, divide by 2. Okay. 6 plus negative 2 is 4, so 4 over 2. 0 plus 4 is 4, so 4 over 2. 0 plus 2 is 2, so 2 over 2. Simplify, 4 divided by 2 is 2. 4 divided by 2 is 2. 2 divided by 2 is 1. And so my midpoint, the ordered triple, is 2, 2, 1. Okay, so this is a lot easier than the previous example and the next two. So why don't you try CYP2, and then once you're done, come check your answer. Okay, so for the distance between these points is square root of 107, or approximately 10.3. And then the midpoint is negative 1 half, negative 1 half, and 19 halves, or if you changed it into a mixed number, 9.5. Okay? If you got that right, you can move on to the next example. If not, here is your explanation. Okay, so basically distance formula for the distance. So 2 minus negative 3, that's the x's, and then squared. Plus 4 minus negative 5, that's the y's, and then squared. Plus 9 minus 10, that's the z's, and then squared. 2 minus a negative is plus, so 2 plus 3 is 5. 4 minus a negative, that's plus, so 4 plus 5 is 9. 9 minus 10 is negative 1. 5 squared is 25, 9 squared is 81, and negative 1 squared is 1. 25 plus 81 plus 1 is 107. There's no perfect square to take out, so it just stays as square root of 107. Okay. To find the midpoint, you add the coordinates and then divide by 2. So the x is 2 plus negative 3, which is negative 1 over 2, so negative 1/2. Okay. Then the y is 4 plus negative 5 over 2, so 4 plus negative 5 is negative 1, so negative 1/2. And then 9 plus 10 divided by 2, 9 plus 10 is 19 over 2. And then if you want, 2 goes into 19 9 times with 1 left over. And there you go. Okay. Okay, so now example 3 is translating a solid. Okay. So suppose an elevator is 5 feet wide. 5 feet wide, 6 feet deep, and 8 feet tall. Okay, so here we see that here. Okay, we're positioning the elevator on the ground floor. Right, and when it says ground floor here, it means the first floor. Okay. So see how this is 5 feet deep. Sorry, 5 feet wide. It is 6 feet deep. And then it is 8 feet tall. Okay. And then using what we learned from example 1, this is how we drew the elevator. Okay. And it's on the ground floor, so that's why you see here for that bottom base, the order pairs or z is all 0. Okay. If the distance between the floor of a warehouse is 10 feet, write the coordinates of the vertices of the elevator after it goes up to the 3rd floor, right? So here, this is on the ground floor or the 1st floor. When it goes to the 2nd floor, it moves up 10 to the 2nd floor. And then when it moves up to the 3rd floor, it moves up another 10 for a total of 20, right? And so then write the coordinates of the vertices of the elevator after it goes up to the 3rd floor. You can see here that all of the z's have changed. So these are the z before. And then now if you compare them, they all have added 20 to them because it moved up 20 feet to go to the 1st floor to the 3rd floor. And there you go. Okay. So really all that happened is that x, y, z changed to be x, y, and then z went up because this is in charge of z plus 20. There you go. Okay, so why don't you try CYP 3A, 3B, and 3C? You don't have to draw it, okay? But CYP 3A, 3B, and 3C, and then once you're done, come check your answer. Okay, this is what you should have gotten. Basically, for your coordinates, all you're doing is adding 15 to x, so these are the points you should have had. Whether you labeled it like I did could be different. I did A, B, C, D, E, F, G, H, and these are the coordinates I got here. Okay. The distance formula, I used A to A prime, so this would be x1, y1, z1. This would be x2, y2, z2, so that it'd be 27 minus 12 squared plus 8 minus 8 squared plus 0 minus 0 squared. Then on this, the 27 minus 12 gives me 15. And then the 15 square and the square root cancel out to be 15, which is right because I moved 15 feet along the x-axis. Okay. And then using the midpoint formula to find the middle, I use the corners, the diagonal, so E, and then it's diagonal across would be C. So I use the coordinates for E here, 12, 8, 10, and C, which is 0, 0, 0. Added them, divided by 2 to get 6, 4, and 5. Okay. So how I got these coordinates was 12 feet long here, 10 feet tall, 10 feet tall, 8 feet wide. And so then that's how I got each of these. So this is 1280 here. Oh, sorry, this should, 1280, because then E is actually the new one. This is 1210, 810, yeah. So 1280, this is 1200, 000, and 080. This one is 12810, which comes from this. Okay. Then F is across this, just back to the 0 though. So that's why it's 12, 0, 10. G is 0, 0, 10 because all it did is move up 10. And then H here is 0, 8, 10. And then since 15 feet along the x-axis, I just added 15 to each of these x's. There you go. Okay, so example 4 here, it says reflect the right triangular prism in the xz plane. So this is the original, okay? And since we're reflecting it across the xz plane, what happens is for x, y, and z, what they are originally, what changes is that y is the one that changes. X and z stay the same because they're on the xz plane, and then it's y that changes its middle, okay? And so that's why here in your book, right, it labels each of them and how it changes. Okay? So since we're reflecting the xz plane, y is the one that changes sign. Okay, and we see that here. All right. So A, which is at 0, -1, 0, what happens? Everything else stays the same. The y changes sign. B here, which is this point here, is 3, -1, 2. They labeled it as E here. So that's a little bit weird. Okay, but then it just changes where the y changes. Okay, C, 3, -5, 0 is here. And then the y changes, so now that's graphed here. D is 3, -1, 0 here. And then the y changes to be 3, 1, 0 here. E is 3, -1, 2. I think they wrote it wrong. Yeah. But the y changes, and then F is 0, -1, 2. And then the y changes to be +1. Okay, so their mistake is that B should be 0, -5, 0. Because it doesn't move this way at all. And it's not upwards, right? It's only on the y-axis that it moves. So B should be 0, -5, 0. And then it becomes 0, 5, 0. Right? So that was their mistake here. Okay. Because there's no way that B and E are the same ordered pair. Which is why it's here. Because that was their mistake on the textbook's problem. Okay, but as you can see, the only thing that changes is the y. Okay, so here on example 4, why don't you try to graph your prism and then reflect it across the xy plane. Okay, this is what you should have gotten. So basically, if it's reflected across the xy plane, it's z that changes signs. So what you can see for x and y, they all stayed the same, and it's only z that changed the sign. Okay, and then so after that, then I just graphed each of those points. It does take a lot of time, and then after I graphed the original, I just erased all of my markings again, so that way it could be more clearly seen, and then I graphed the other one as well. And there you go. Okay. So that's it for today. Thanks for hanging in there. The hard part is probably the graphing, but you just got to be a little bit patient with it and just graph each point by point and through the making of those different diagonal lines and stuff like that. But as you keep practicing more and more, it gets a little bit easier to know, oh, you don't have to actually measure all of the points and always like sketch each of the lines, right? So like, for instance, with A and B, right, it's kind of easy to know, okay, 2, 2, right, for that Y and Z part and stuff like that. And then if the X is the same, then I know, oh, I can just kind of go across that way and stuff like that. There you go. So that's it for today. Have a great rest of the day. Bye, guys.